Right. So welcome everyone to our monthly meetup of AWS User Group Colombo, April. So usually we do this in the physical way, but we host meetups every month. But this time, due to some reasons, we decided to go with an online session. So today we have an experienced speaker with us. Uh, he's not an in he's a very familiar face for AWS user group. So today we have Lakindu Hevavasan, technical lead at Search Global and AWS community builder. So he will be talking about zero trust in regions and how to architect an AWS for the worst case. So without further ado, let me add Lakindu to the stage.
Yeah, hi,
Hi
Samir.
Lakindu.
Hi.
Over to you.
Yeah, thanks, Samir. So I'll quickly share my screen. Okay. Let me know when you can see my screen. Yeah. Is it visible? Yes, it is. Okay. Cool. All right. So today we're going to be talking about something very interesting. So it's basically about how you can build your AWS applications to design and handle worst case scenarios. So basically, you might have seen a couple of issues where you have had a lot of data centers going down recently due to all of the political crisis that has been happening across the world. And because of that, many people have been losing access to their regular AWS workloads, and they've just been had to stand still basically. So that's mainly what my session's going to cover today. So I'm not going to introduce myself. It's pretty straightforward. I'm Lakindu, and I've been working at Search Global now. And I'm a certified AWS solutions architect. And what I do is I basically build solutions that revolve around AWS. So during like March-ish and April, so there have been several disruptions across AWS regions in the Middle East and Dubai, Bahrain, and so on. And we've also had a lot of other outages across last year, which have impacted several AWS regions like US East 1, which has caused many popular sites like Adobe Creative Cloud, Canva, Slack, Pinterest, Reddit, Snapchat to all have disruptions. So when you have outages like this happening in the industry, it's common to think about how can you handle such failure scenarios in the industry. So when you build systems, what should you consider? Basically, how do you handle multi-region architectures and multi-region systems? And when things go wrong, how do you ensure that your customers are able to access your systems with minimal downtime? So that's basically the talk about. So we are going to be talking about fundamentals on how you can design a system like this and what strategies and trade-offs you should make, because at the end of the day, no system is going to be fully available or fully performant. So there's always going to be the best case scenario and the worst case scenario, and you have to design your system in a way which handles that pitfall as well. So if you take a look at building on AWS, the AWS global infrastructure has close to about 40-ish regions. So this image, it might not be up to date. And it has over 100 availability zones and a couple 600 odd point of presence available. So you can build your application all over the AWS global network. So you might have, if you were building an application that is serving customers in the Sri Lankan subcontinent, you might want to deploy your application run in Singapore, because that is where the most direct access to Sri Lanka is. So with stuff like that, what you want to consider is, if Singapore goes down, how do I handle that problem? So when you think about multi-region overall, there's a lot of benefits that happen when you go multi-region, right? So the first best benefit is you have improved performance. So let's say you have an application running in Singapore, you have it in Europe, you have it in US, you have it in Dubai, you have it all across the world. That same application, right? You have multiple instances, and all of that is routed through like Route 53 using your global DNS. Now, you can have configuration setup where each deployment is configured as the primary instance. So it's like an active deployment. And based on the user's current location, you can route your requests to the server which has the closest location. So that is what you call as proximity driven routing. And you also have really good availability. So when systems go down, you can have automated system failovers. This helps you manage quick downtime so you don't have a big downtime in your application overall. And then you also have really good compliance. So for example, if you want to serve the customers in the US or EU, you can have your deployments running in the US and EU so that requests from the European Union only go into that specific region, so that your data doesn't, or your network and data does not leave the EU data centers, to help you achieve your compliance. And when you take a look at designing this to get all of the benefits, you have to consider about your first cases. Even though you go multi-region, you have to think about the fact that if you are available already on a single region, right? So what does that mean is, are you using your availability zones correctly? So majority of the time, what we see is when you design an application, you tend to only deploy it in a single AZ. So at that point in time, if that availability zone within that region goes down, you lose availability of your application. The second one is scaling policies. So how are you scaling already? Do you have policies set up so that if one node has X number of CPU requests, so if your CPU usage is higher than 75%, 80%, or if your RAM is being used overly, do you spin up another node and load balance within that specific cluster? That's important. And the third concern is, have you designed your health endpoints correctly? Now, in most cases, what we generally see is you have a health endpoint, which is like api.com/health. That simply returns an OK endpoint with a response code of 200. But that doesn't really tell you what's happening inside your system. So you have to consider if your databases are healthy, if your third-party integrations are up and running, if your message buses are working. So you have to ping them to see if they respond and acknowledge well, because your health endpoint should be an indicator that your entire application is working and not just a single part of your application. So when you design an application, you have to make sure that that criteria is met as well. And do you have a single point of failure? So many instances, let's say you might have your application in front of a web application firewall, and that application has multiple nodes running, and that is load balanced via, let's say, round robin, and your firewall instance is simply a single node. So if your firewall is the entry point of your application, regardless of how your application scales, if the firewall goes down, your application request won't get routed onto your application, making your application unavailable. And the next part is, do you support horizontal scaling already? A good example of this is if you have been using scheduled jobs. If you are using something like .NET, you have the Quartz library, and in that, if you by default, if you do not configure it correctly, it uses an in-memory job store. So what that means is all of the information about when's the next scheduled job gonna run and what node is handling it, everything is stored within that instance. And if that goes down or restarts, that state is cleared. So the moment you have multiple nodes, you have to make sure that this is globally accessible and globally distributed, so that every node handling this event uses the same source of truth. Because then at that point, you avoid instances where you have double invocation of scheduled jobs and so on. So make sure you have support for horizontal scaling, and make sure you handle blast radius properly in your application. So if you have really big throughput coming in, make sure you have implemented a bulkhead, or you have circuit breakers running in to handle your fault tolerance properly as well. So regardless of your application supporting multi-region, if you can't make yourself available in a single region, you can't survive a multi-region deployment. Once you have done that, you have to then take a look at your RPO and RPO. right? So these are two key availability metrics that you have to think about from a business standpoint before you make any decisions about how available your application is going to be. So for those of you who do not know, RPO is basically your recovery point objective, and RTO is your recovery time objective. So what this means is, at in the event of failure, your recovery point objective is how far back in time can you accept data to be available. Like, can you have 5 minutes data loss? Can you have 10 minutes of data loss in the event of a downtime? Some systems might not accept that. For example, if you are working in like the stock exchange, or if you have had like a booking system or like a bank, you can't accept downtime of data or loss of data. So that's something we discuss with the business team and then come to a mutual agreement on to decide how far in time you can go back. And then you have RTO, which is basically your recovery time objective. Now, this basically states, in the event your application does go down, how long would it take to get it back into a working state again? So that's again something that you decide. So if the business says they want it done within 30 minutes, you have to make sure your system is capable of restarting, failovering, and bringing itself back to a functional or usable state again. Now, when you take a look at these two, this helps you determine what kind of workload you're working on. So each criteria, if you have a resiliency tier of platinum, which is you have your RPO of 5 minutes, RTO of 15 minutes, that is for a mission critical application like a stock exchange system or a bank. But you have to understand that the more closer or limited time you have in order to get yourself back up and running, and the data loss state, the more expensive it is to maintain these architectures. So that's a trade-off that you have to make. If you want really great RPO and RTO rates, you have to make sure you invest a lot in your infrastructure. Once you have deduced these two factors, you can then derive your SLA on how much downtime you have per year. So depending on this, you can start designing your architecture. So generally, before we get started with any application development, we generally have the architects coming in, and then you have the business side coming in, and then the product owner coming in saying these are the functional requirements and these are the non-functional requirements. So you have to identify the non-functional requirements clearly and get indication on what the availability of the system needs to be. With that in mind, you can ensure that you don't end up over engineering your application. So a simple to-do application, you don't need it to be available 24/7, and you don't need it to have an RPO time of 1 minute. It can handle a downtime. So that's important. So once you have established that, you can then move on to the next phase. You say, hey, what components do I need in order to build the system now? The first thing is picking your database. So for this, you really have to understand what kind of data you are dealing with. And when we generally do this, we tend to take a look at three aspects: consistency, partition tolerance, and availability. So consistency really says that how accurate does my data need to be in a distributed environment, and availability is how available should my data be, how often can it not be accessible in a year. And partition tolerance is, in a distributed system where you have network failures, how can it handle this specific downtime. One thing to take note is you can't ever achieve all three in a database design, right? You'll always have to trade off on one aspect. So if you were focusing on a system which has really good partition tolerance and consistency, you'll likely be trading off on availability, because in order for a database to stay extremely consistent, it has to maintain synchronous write operations across your environments. So for this, it might not be able to handle specific delays in your data. So your data might not always be available when you need it to be. So make sure you do that. So figure out if you want availability or consistency. And depending on that, you can select the right database system. Basically, if it's relational, non-relational, and if it is relational or non-relational, what kind of database. So once you have understood how consistent your data needs to be, you can think about, hey, does my data need to be eventually consistent or strongly consistent? So what you mean by eventually consistent is that's basically a scenario where you have asynchronous data replication. So for example, if you hit your data on multiple regions, you have, let's say, RDS running, and each instance is running on 3 availability zones. Now, within an availability zone for a single region, this data is immediately available. So this is strongly consistent within a region, but cross regions, it's eventually consistent, meaning that it will eventually be replicated across your systems through like log file replication. So it writes the data to the log file, which is then propagated across the regions that you have RDS running. So this is not gonna help you get accurate data, up to date data, basically, but eventually it will be up to date. In order to determine this, one tip that I always think about is, do you have read heavy operations or write heavy operations, right? So if you have read heavy operations, consider patterns where you have eventually consistent operations, because you might need to make sure your data is immediately persisted without a delay so that they can be fetched back when it's needed, right? So make sure you guys really see if you have that functional requirement saying your data has to be read heavy or write heavy. And based on that, you can decide how you want to design your architecture. So again, in this specific scenario, we have two regions which are serving on an active scale. And what this happens is, when you use DynamoDB global tables, what it does is it has an approach like read local and write global data syncing states. So what this basically means is, in order to read data, it uses that region that the request is coming from, right? So depending on your active state, uh, if this specific region on the right receives a request, it will use that to read, it will use the region on the right to read. But let's say that you have a specific write operation coming to your database. So let's say the user wants to update their information. So at this point in time, what it does is it keeps one specific region as the determined write region. So that's why it's known as your read local, write global. So it writes data to one region, where that region then propagates the update across the other regions so that they're available eventually for a read. So one question you might ask me is, in the case where your write region goes down, how do you handle that? So in that point in time, you might have to have some kind of algorithm where it monitors the health of the write region, and when it goes down, it promotes a secondary region as the next write region, basically. So this is a really good operation for read heavy applications where your data is eventually consistent. And then you might have read local and write local. So what this does is it reads and writes data within that specific region. It does not have a global write region. So every region has a write and read operation. And if one of your regions goes down, the other regional is functional with health-based routing on Route 53. So that's basically your active deployments, where you have two active regions, and Route 53 serves traffic based on the load or geo location, latency driven, so on. The next thing is, you have to always ensure that you do not have services cross regions. So let's say that your main application is running in AP Southeast 1, and you end up using an email service, OS3, which is located in US East 1. So if US East 1 is down, that means your region has a dependency, your main application has a dependency to US East 1, even though it's running in Singapore. So you have to always consider the fact that if US East 1 goes down by chance and SCS OS3 is affected, my application will not be usable. So one best practice is you have to make sure that a failure in one region does not impact another region. So make sure you don't have region related dependencies. Once you have basically considered all of the data requirements and region requirements, you can then think about how do you want to fail over your application, right? Now, the first way is a component level failover, right? So let's say you have SCS, SNS, SQS running in Singapore, you run into a failure on one of those specific services. You immediately have a secondary region running in Japan, maybe. What you do is you fail over that specific component onto that specific region so that it continues to be operational. So this is what you call as a component level failover. This requires specific manual configuration so that you know what region to talk to, if you want to talk to this specific service. But this might sound easy in paper, right? You just switch a service to another region, it works as normal. But it has really big drawbacks like latency. One thing you have to consider is regions are geographically located far away from each other. So they add a really big network hop. And this can increase your response time and drastically reduce your system performance. And you have to make sure you manually update your application configs to switch your components to secondary region. Finally, this becomes a really big problem to test, because if you have a lot of components and if you are running a serverless architecture, you probably have a lot of serverless components like SCS, SQS, SNS, Lambda, so on. If these fail, you have to map them to a secondary region, manually handle all of your routing. So that's going to be a bit harder to debug, and it creates a really big dependency chain for you to handle. So it's not a really big benefit, but it does give you that cost benefit where you don't have to maintain an exact version always up and running if you want to serve another, if you want to have a downtime. The next one is a full application level deployment, right? So you have to consider how would you do this. You have the exact copy running in two regions, so it's the exact same configuration and the exact same specifications, and you use Route 53 to do a DNS level failover. So what you do is, on Route 53 you can configure health checks which talk to your health endpoint constantly and monitor if your application is healthy. And if by chance one of your regions are not healthy, Route 53 will immediately fail over to your secondary region, and that is being promoted as passive, as an active. And when the secondary region or the now passive region comes back up, it will route itself and switch the DNS records back, and it will continue serving traffic in the ordinary way. So that's how you would really do a full application level failover. So a couple of issues that you have in this approach is that it is extremely costly, because you have to maintain a really big environment. If it's, let's say, a single AKS cluster, sorry, an EKS cluster, you have to maintain an exact deployment of your EKS across both regions, your VPC configurations, your NAT instances or NAT gateways. If you're using NAT gateways across multiple availability zones, you have to make sure that all of those availability zones are covered. If you're using RDS, you have to make sure the same version of RDS is running with data being synced properly. So that's basically gonna be double the cost. That's gonna have a really big investment up front, but that is only if you really need an application level failover. So it depends on how mission critical your application is. In most cases, you really don't need a full application level failover, but if you are in a scenario where you are working with a really sensitive use case where 24/7 availability is key and you can only have around 5 to 10 minutes of downtime per month, this is a good option for you. But one other drawback is you don't have readily available caches, readily available data on your Redis instances if you have them running. So it will take a while in order for your caches to get populated again. By doing so, this might exert a lot of throughput on your database immediately. So that's basically an application level failover. Now, those are like the one of the key main areas that I wanted to cover basically. So how do you fail over an application in a component level? How do you fail over an application in the DNS level, so basically a actual region failover, and what are the drawbacks that you have on each approach, and why you have to consider each approach in terms of your relationships to your data and your NFRs and so on. So what I want to leave you guys with is, when you design systems, always make sure that you don't assume that your region stays up 24/7. So this scenarios with what happened in March, April across AWS regions in the Middle East is a really good example that you can't expect regions to be up 24/7. So think about regional failure at first to see if your business needs it. If so, plan for it. And if you want to implement it, consider using Route 53 for it. Don't always assume that your data is going to be consistent throughout. So that's one of the problems that I see that people have, is they assume that if you are immediately in like DynamoDB, they assume that DynamoDB is strongly consistent by default, but that's not true. DynamoDB is able to have really high performance because of its eventually consistent nature. So if you have strongly consistent writes and reads, that means that your application will take a bit more time syncing data across its regions. So pick your cap trade-off. That's basically your consistency, availability, and partition tolerance. And good ways to implement this on AWS is if you are using DynamoDB Global Tables or Aurora Global. The next part is what I thought of when I first started thinking about multi-region architectures and availability in general. I simply thought that it was just a percentage that business decides, say, I want to have my application 99% available. But the more you work on these problems, you realize that it's not just a number. It's basically how you think about your recovery point objective, your recovery time objective, and work with the business, understand its requirements, understand its need to serve its consumers. What type of customers are they serving? How critical are they? What happens if they don't perform these operations? What are the negative impacts of this? So those are some of the lessons that I learned, how to think about availability. So based on that, you can decide if you want to go on a platinum level availability, gold or silver level availability, and design your application to fit that. Because sometimes, like we said, it's not needed in most cases. So the next failover doesn't just work. It works for pretty AWS managed services like Lambda, but it doesn't work if you are managing the infrastructure on your own, specifically in a multi-region application, right? So it doesn't just automatically decide, hey, I'm going to failover because this is just not working anymore. What we do is you plan for a mandatory DR drill, possibly every 6 months is what we do. We try to simulate a fault in regions using AWS's fault injection service, and by with that we can assess to see how long it takes for a region to come back up and how much data we have lost so far. And then two more things is, don't always assume that your dependencies follow you in the case of region outages. Always build systems that are region independent, right? So don't always build systems that have cross-region workloads, because it doesn't only make your system risky, but it also adds network latency as well. And when you are designing multi-regions, don't simply assume that, hey, this cost will likely have an ROI in the next 5 to 10 years. That won't happen. Always ensure that your workload is fit for your specific use case. By doing so, you can come up with what we discussed, your platinum, gold, and your silver tiers of availability and resiliency, so on. So that's pretty much what I wanted to highlight in general. So I know it's a bit of a short session, but what I wanted to talk to you about was, we went on a drill from the months of March onwards. We have been designing a lot of multi-region deployments these days because it's become a need for the workloads that we function in, and it's kind of something new that we've been working on. And what I've had with my conversations with other people in the industry is that they've also not build applications to that specific scale. So what I wanted to share was the knowledge that I've gotten out of it, and to show the lessons that I've learned, and basically what you should consider when you think about it, because it's not as easy as it seems, because building these systems have a lot of dependencies in it from the services you use, because sometimes your secondary region might need to go through strict data compliance checks. So if it's specific EU related, you might not be able to move to another region unless you have specific approval from a government body. So likewise, you have to consider that it's not simple as just spinning up another region on your own. So yeah, feel free to connect with me on LinkedIn if you do have any questions, and we can take it from there. So thank you guys. Yeah, that's it from my side.